So you've built an app, designed your schema, everything seems perfect. Then something comes up that requires you to change your data model. You need to figure out how to change your data model and rewrite your application logic so that it can use the new model. For example, when your app started, maybe you were storing one email address per user, but now you need to store multiple addresses. You could add additional columns such as email 2, email 3, etc. However, a better way is to use a list of email addresses. While the most future-proof way to go is to use an embedded list, the problem is all your existing users are stored with email address fields directly in the documents, rather than in the email addresses list. In addition, all your existing code is using the email address fields on a user, not from within the email address list. So what do? This is where you can use the Schema Version Pattern to your advantage. The Schema Version Pattern is a way of assigning a version to your data model. This is usually done at the document level, but you can also choose to version all of your data as part of an API. It is recommended that you always assign a version to your documents so that you can change them in the future without having to worry about immediately migrating all of your data and code. If you're using Redis Stack, your schema is flexible, and you can make changes to your existing schema without any downtime. If you aren't already using the Schema Version Pattern, the good news is you can start today without making significant changes to your application logic. Let's dive into some code to see how you might apply the Schema Version Pattern to your existing codebase. Here, I'm importing Redis OM and defining a user schema with name and email fields. To create a new user, I need to save the user data to Redis Stack and then return the new user. To get a user, I simply fetch it from Redis Stack using its unique ID. Finally, to update a user, I fetch it by ID and then update the fields. In a full production app, you might do a lot more than this, but this is a simple example of how you might start writing an application to create, read, and update users. Now let's see what this looks like in Redis Insight. In Redis Insight, you can see that I've inserted 2 users into my database. If you click on each user, you'll see that there is a name and email field. This is working well for now, but what happens when we need to change users to have a list of email addresses? We need to change the existing schema and write some new code to migrate old users to the new schema. The best way to do this is to create a translate function that you run whenever a new user is created or when an old user is updated. The reason you want to do this is twofold. First, you only want to migrate a user document one time, so you don't want to translate it during read time. Second, you want to allow your existing applications to continue to use the older schema. Let's see how we might incrementally migrate old documents to use the new schema while supporting existing application logic. Once again, I'm importing Redis OM, and this time I'm defining our user schema with additional fields for schema, contact, and an emails list. I chose to eventually rename the email field to contact so it's more straightforward. However, I didn't want to remove the email field yet because I still want to support legacy code. Now, I'll start by writing a translate function that will translate data from the old schema to the new schema. By default, I'll assume anyone using the function is still using the old schema. This is safe. You don't want to automatically assume everyone wants to start using the new schema. In the translate function, I'll do nothing if the old schema is in use. I'll also do nothing if the schema of the incoming data matches the schema in use. If neither of those conditions are true, I'll migrate the old schema to the new format and return it. Now I need to write the create function to support both schemas. Once again, I'll use the old schema by default. Then, I'll call to translate the data, save it to Redis Stack, and return the JSON. Updating an existing user can be a little bit tricky, so watch closely. First, I fetch the user from Redis Stack, then I make a call to translate the incoming data. Finally, I update the user fields according to the schema in use. Now let's see what this looks like in Redis Insight. In Redis Insight, you can see I have 3 users. I took the liberty of creating a new user using schema 2 and updating an existing user using schema 1. When I click on the first user, you'll see it's using schema 2. Note that the email field is missing in Schema 2, so it isn't stored in Redis Stack. For the second user, I updated an existing user without switching to Schema 2. For this reason, you'll see a schema field with a value of 1. But you won't see any fields related to the new schema. The last user hasn't been touched since I wrote the code for the new schema, so you won't see a schema field here or any fields related to Schema 2. While this may be a contrived example, the principles still apply in a real-world application. You should always use the Schema Version Pattern to aid in incrementally migrating your data as your data model changes. Thanks for watching. If you like what you see and you want to hear more, please like this video, comment, and subscribe to our channel. Also, be sure to check the description down below for a link to sign up to Redis Enterprise Cloud for free.